So I wanted to talk today a little bit about the inheritance structure of the payment terminals in the V3 repo. So this is Juice Contracts V3. It's a pretty hefty code base. There are some abstract contracts. These are classes that aren't deployed directly, but other contracts, mainly these chunkers here, may depend on them or borrow from their code and extend them and do a little bit more. There's some enumerations in here, like ballot state, fee type. There's a whole bunch of interfaces, and interfaces are essentially their definitions of what a contract could do. So the one that we'll be really focusing on is this IJBPaymentTerminal interface. And these all are led with the letter I here to symbolize their interface. And all this does here as an interface is specify functions that should be implemented if a contract were to adhere to this interface. And it creates this standard so that anyone in the outside world doesn't have to know how a function is implemented. It just can know and have strong guarantees that a contract does in fact adhere to these functions, which is really nice when you're building composable things. As we saw with the Delegate videos last week and the hackathon we just ran, essentially all the Delegate is an interface, mainly the IJBPay. See, yeah, it's a problem with the large repos. All these names kind of get tangled up, but it serves its purpose. IJB Redemption Delegate, for instance. If you're going to build a redemption delegate, all the protocol needs to know is that if you have a contract that says it adheres to this, it probably has a did redeem function. It doesn't really care what it does. So you can bring your own functionality. It's just going to know that it has a did redeem function, and therefore it can pass a data object into that function of yours. So interfaces are useful for this composability pattern, but they also create some trade-offs, right? You have to figure out, you probably don't want a new interface for every single function you have, because then you are subdividing your routines and your expectations really thinly. It's very hard to reason about why something is something else. When coding, we also kind of use the word is to mean it adheres to a certain spec, a certain interface spec. So for instance, if your contract is an IJB redemption delegate, it means it has this function here. And so when thinking about interfaces, you want to find common chunks of code and functionality that really define what something is, and then try to abstract that away from other bits of code that maybe take that more foundational set of expectations and then constrain it further into kind of smaller pockets of expectations. And when building the base JB protocol, we have to be pretty particular about this, especially with the things like payment terminals, because the baseline standard for rolling a payment terminal should be rather simple, right? Essentially, all we really care about is knowing that if you have a payment terminal, I can pay a project. So it just needs to have this pay function that takes all of these properties here, these arguments. It needs to know which project ID I'm paying, how much is being paid, which token is being paid, who's the beneficiary of anything that gets returned kind of as a function of the payment. How many of these returned tokens should I be expecting? Do I prefer to have these tokens automatically claimed into an ERC20 or whatever format, or should it just keep accounted for in the protocol itself? Should there be a memo attached to the event? Then is there any metadata that the payer wants to pass in case there's some extra functionality through delegates or whatnot? And essentially, if you want to run a payment terminal, if you want to run a new contract and attach it to your Juicebox project, you should be able to write a very simple IJB payment terminal and attach it to your project so you can start accepting funds there. And it can be as simple as rolling this, and the only thing the function actually does is maybe forward any received payments to your address or something. So just skip all the fancy stuff about JB and basically just make a payment terminal a wrapper for boring old ETH transaction, which would totally work. And the way JB is designed is such that no one can tell you as a project owner what you can and can't attach to your project. So you can roll your own payment terminals and be as creative as you want here. You can start from the stuff that JBDAO has put forward as convenient for you to use, but you can always evolve into your preferred way of operations over time. So it has the pay function and also has this add to balance function, which is basically, okay, most JB stuff is oriented around pay, which means there's an exchange happening. And add to balance is just, I'm just going to dump funds into a project ID's balance, but I don't expect anything in return. So these are the two functions. So again, you can imagine this being two different interfaces, that one has pay and one has add to balance, but it gets a little messy when you subdivide it that much. You want to find these similarities. And this is the core nugget of what a payment terminal is, and it's expressed in IJB payment terminal here. There's a few view functions as well that are expected to be implemented. The terminal should know if it accepts a particular token for a particular project ID. So if asked, hey, does this project ID accept this token? It should be able to say yes or no. It should know the currency for a particular token. It should be able to answer, hey, what currency should I do you expect to use when I pay in this token? And how many decimals are you expecting in the calculation of this token? Because numbers in Solidity are expressed not with decimals, but rather with fixed point numbers, meaning if there's 18 decimals, then you can expect 18 zeros padded against the number you actually want. And then lastly, it should return the current ETH overflow of a project, normalized to ETH. So if your payment terminal is accepting some other token, let's say USDC, current ETH overflow should return the amount of ETH that is worth. And the reason for current ETH overflow is because the sum of all payment terminals a project has should be able to report how many tokens that this project has should be made available for in the redemptions calculation. It's kind of a core part of JBs. Any funds that are in overflow across the project should be incorporated in the redemptions calculation. So if you're rolling your own JB payment terminal and there's nothing in here that should be redeemable by users or by token holders, by whoever, then you can always return 0 here. You can return your own version of this calculation based on how much you want to kind of value whatever's in this terminal. But I guess standard functionality is just convert it to ETH and return that so that redeemers have a fair value. So this is all a payment terminal really has to do. The way we interact with payment terminals on a day-to-day basis is a lot more involved than this. We have payouts, we have redemptions, we have means of holding fees, of taking fees, of like all these little things that are useful, but they're all built on top of this core IJB payment terminal interface. And if the other core contract that makes up JB is this JB directory contract, which I'll go to here. The JB directory is a directory for every project of which payment terminals the project is currently accepting funds through, and which controller the project is currently being controlled by. And as far as JB directory is concerned, it just cares that it's IJB payment terminals. So it doesn't care how fancy your terminal is. It doesn't care what else it does. It'll just have a strong guarantee to whoever asks for payment terminals from the directory that it at least implements these functions here. So this is like the baseline stuff, right? So whenever you go to, in a really common pattern when you're working with Juicebox and you're integrating a certain piece of functionality or extending a certain piece of functionality, is either checking that something being sent is a payment terminal that the project has, or like maybe a call is coming from a payment terminal the project has, or you want to get the project's current place where it's accepting a certain token in. For instance, I'm just going to hop between these two maybe a few more times here, so bear with me. But the function here, there's terminals of a project and there's primary terminal of a project. So I can go, all right, for this project ID, what's the primary terminal for ETH? So if the project has several tokens that accept ETH. If someone in the world asks this directory, where should they send ETH? Return this particular terminal. When it does so, all that extension contract would know is that it for sure is able to be paid, and you can add to balance. Everything else, it's going to be an assumption, which is part of the expectation that project owners can bring their own piece of functionality there. So we're not going to hold them to some fancy standards. All we're going to hold them to is this standard. So anything that comes, any expectations that come past the standard, you have to have a compatibility for. And so if you're looking to do some redemption, some piece of redemption functionality or something else, you want to make a check after you get the payment terminal back that yes, it does in fact also accommodate redemptions. I'm going to keep in the abstract for a little longer, and then maybe we'll do a shift over to examples in a bit, so we can actually see these things in practice.
Sounds good.
So this is the lowest level, IJB payment terminal. And let's go to the highest level, the actual contract that gets deployed that JBDAO currently accepts funds through. JB ETH payment terminal 3.1.1 in this case. All this contract is a very short extension on this contract here. JB payout redemption payment terminal 3.1.1. So by its name, you can tell this is a payment terminal that also does redemptions, that also does payouts. So how is JB payout redemption terminal organized? This is an abstract class, so it never gets deployed directly. It gets deployed by JB ETH payment terminal and then also JB ERC20 payment terminal, which does the same thing, but just says, cool, the token is ETH. And the other one says, cool, the token is an ERC20. But in the abstract, it says, I don't really care which token it is. All I know is that I'm a payment terminal and I do payouts and redemptions. And this is the most functionality in the Juicebox protocol, like the ones you interact with are in this file. So we'll go through it briefly, but first I'll call attention to what it is. I'm going to start from the back here. It is an IJB payout redemption payment terminal. So it's the same, it has a particular interface that characterizes this particular implementation. So we're going to jump files around a little bit and we're going to go find that thing. And then we're going to go back to where we just were here. So IJB, it's always the longest name here. It's easy to find. Cool. IJB payout redemption terminal 3.1.1. 3.1.1 is the same thing as 3.1. It just has a few extra events. So that's great. We can always have the strong guarantee that if you have a piece of compatibility for 3.1, it's also compatible with 3.1.1, which makes sense in the naming. So the interesting stuff is actually going to be in the .1 file here. Here, you're going to have some more inheritance nesting. So you can already see how this can be very confusing. And even in explaining it, it can be confusing without some visual. So I apologize for not bringing a visual here. Maybe we can come up with something. But you'll see that IJB payout redemption payment terminal it's a payment terminal, right? So it has that base class. It's also a payout terminal. It's a allowance terminal. It's a redemption terminal. And it's a fee holding terminal. So it's basically, it has this base functionality, but it also stitches together a few other expectations that when taken as a single contract contains all these bits of functionality. So if your extension specifically needs to know that whatever payment terminal I receive from the directory is a redemption terminal, this would qualify since it adheres to IJB redemption terminal. And you can expect, or I guess you can maybe guess what IJB redemption terminal has is this expectation, right? That it implements redeemTokensOf, which is your classic JB redemption function. Who's redeeming from what project, how many tokens, et cetera, et cetera. So this is the case where we do scope it all the way down to its tiny kind of one function granular bit because we want to make sure any payment terminal can also roll out redemption functionality and have cross-compatibility with any other terminal someone rolls out and also wants redemption cross-compatibility with, which is really useful for clients and other folks who are building extensions. That way you can make whatever you want as long as it has that one function, it knows how to interact. In this file here, you're not going to re-implement all of these specs here. So you won't find that redeemTokensOf function in this file, nor will you find the pay or add to balance. You're going to find all the stuff that makes this particular implementation special, but it's also going to borrow all of these standards as well. There's just a bunch of stuff that it keeps references to, like the directory, the split store, the project store, etc. Cool. So now we're going to pop back into this main abstract implementation here. So we just looked through IJB payout redemption payment terminal, and we're also going to make sure this contract is ownable, which is an Open Zeppelin standard. We're going to make sure it's JB operatable, which means there are certain functionality in here that a project owner can specify an operator that can call it on project owner's behalf. So it has some utilities to manage those responsibilities. And then another payment terminal thing that it is. So now we get into this weird kind of nesting of stuff. JB Payout Redemption Payment Terminal 3.1 is a JB single token payment terminal. So you'll notice this one does not have an I next to it. This is actually this file right next to it, which is also an implementation. So the interface down here is just a bunch of function declarations that it must implement here, whereas JB Single Token Payment Terminal is an actual contract implementation. I'm going to click on it now. It's an actual contract implementation that it itself has an interface declaration. So by virtue of this taking on all the functionality from JB Single Token Payment Terminal, it also is a IJB Single Token Payment Terminal. And so in order to understand what this whole contract here is, like this is the one that our goal is to understand this contract. In order to understand this, we had to understand what this standard here was. We had to understand what IJB Redemption Payment Terminal was. We had to understand what IJB Payment Terminal was. And now we have to understand what IJB Single Token Payment Terminal is. So let's go take a look. IJB Single Token Payment Terminal. Lucky for us, it's pretty simple. So all IJB Single Token Payment Terminal it's just an IB payment terminal that also has a few extra expected getters. It has a token, which is an address. It has a currency and decimals. So basically, all this is saying is, great, IJB payment terminal can take payments in various currencies. You can add to balance of a project in various currencies. All I'm trying to do here is tell you that I'm a payment terminal that only cares about one token. So don't overthink it. I'll tell you upfront which token I care about. I will not accept anything else, and that'll make everyone's lives a little easier. But obviously, if you don't want to be a single token payment terminal, you can just be a payment terminal, and you can accept various currencies in the same place. But up until now in JB contract implementation life, we've only used single token payment terminals. We have the ETH terminal, which is the only one we've actually used. We also have an ERC20 terminal, which hasn't been accessed through clients yet, but it's in the contract repo here. And even the ERC20 token payment terminal, you deploy it specifying which ERC20 it receives. So it is also a single token payment terminal. You have to deploy a new terminal for each ERC20 you want to accept. You could also write a ERC payment terminal that can accept any ERC20, but there's definitely some complexities in managing those balances if you do have that open-ended expectation. And for now, we just we're very focused on a few specific use cases. We don't want to kind of cross wires when we're dealing with these monies. Okay, so where did we use this from? We use this from the IJB Single Token Payment Terminal. So you'll notice it implements those expectations. It has token, it has decimals, it has currency. It also has all the things that IJB Payment Terminal needed: accepts token, decimals for token, and currency for token. Unsurprisingly, all it does here is accepts token for project. Well, is it my token? Yes or no. So it doesn't care which project is sent here. It just says, is this the token that I manage? Decimals, it doesn't even do any checking. It just returns its decimals. Currency also, it just returns its currency. So it does adhere to the IJB payment terminal standard. You can treat it just like any other payment terminal, but it also has this extra constraints here because of this IJB single token payment terminal adherence. And apart from that, it doesn't do much else. It just, in order to make it, to construct this contract, obviously it needs to know what's my token, what's my decimals, and what's my currency. And that's it. So now we might have a fuller understanding of how this works then. We have a JB payout redemption payment terminal. It is a JB single token payment terminal, so you can expect it to have a token, a currency, and decimals. And it is also expected to implement any functionality in IJB payout redemption payment terminal 3.1.1 that hasn't already been implemented in this base class here. So it's basically everything that's not those basic functions, these accept tokens, decimals for token, and currency for token. So here you can expect it to have things like, let's just scroll down, it's a long file. So things like pay, here's the implementation of pay. Things like redeem tokens, here's that. Distribute payouts of, this is found in, if we go back to the interface for the payout redemption terminal 3.1, this is from IJB payout terminal. So IJB payout terminal 3.1 has distribute payouts of. So it needs to implement that. And here is where it implements it. And then you'll take my word for it. I won't keep jumping around the files. That use allowance is one of those expectations that it needs to implement. The migrate functionality is expected only if a contract adheres to IJB payout redemption payment terminal 3.1. So a regular IJB payment terminal won't know about this migrate, neither will the single token payment terminal. It has to be this. And so you can imagine, like, okay, cool. From an integrator's perspective, the steps are as follows. First, if I were to be building a migration extension, I'd first want to go to the directory and get where is all the money. So JB directory primary terminal of project ID and token. So let's say for project 100, which payment terminal is it accepting ETH from? I get that payment terminal back as an IJB payment terminal, but then I need to cast it to this interface, IJB payout redemption payment terminal 3.1, in order to be sure that it has this migrate functionality implemented. And so in order to do that, I can make the assumption that it inherits from this contract here, or I can do a check that it inherits from this contract here. And the way I would do a check is I would, on whatever contract I get back, I would see if it supports the interface. And this is kind of an ERC 165 standard that contracts can implement to report to the outside world if given an interface ID, which is just a composite of everything that makes up the interface, if it does adhere. And all this is saying is, like, if it matches any of these, then return true. So whichever the integrators can have confidence that, yes, the payment terminal that you got back does in fact have this functionality, and you can cast it into that type. For those who need a little extra context on casting, it's basically you have an address, for instance, a vanilla Ethereum address, which looks like every other vanilla Ethereum address, which isn't very useful unless all you want to do is send it funds. And so in order to make the assumption or the assertion that this address also can do other things, you need to cast that address into a particular type. And all of these things that we've been talking about are types that have these extra functionalities. And once you've cast that address into a type, then you now have access to anything that that type does. It's a little complicated. It's definitely worth teasing out some examples here as the next step. But that's the gist of payment terminals and an inheritance of payment terminals. And to review, the purpose of all of this is to be able to build from the smallest nugget of responsibility that a payment terminal must have, and that is receive payments. It doesn't have to have anything else. You don't have to have redemptions, payouts, anything else. All it has to do is receive payments. And if it receives payments, people can feel free to bring their own payment terminals that do creative things and attach them to their projects. Everything else are expectations that we kind of layer on top of that in themselves can be shared between other payment terminals. So if you want to bring a payment terminal that also does redemptions and payouts, you might also want to adhere to standards that are already being used for those bits of functionality in contracts like this, like the JB Payout Redemption Payment Terminal. But you can also roll your own standards out. Contracts like this won't adhere. And so for projects in the JB ecosystem, using contracts like this, the extension just won't be able to assume that it can do what it expects to do. It's all a little confusing. Definitely takes some intent when you're building an extension as to like deciding what you're trying to do and what you expect the objects that you get back to be able to do from the first place. And if you don't really know, then you have to do a little checking to make sure the versions are right and that the expectations are correct before you actually do a thing. But the end result is we get a really flexible environment where no one really has to be in control. Anyone can have a lot of creative freedom and start their business or project with kind of tools that are baked in and provided by JBDAO, but then eventually evolve into tools that are more proprietary if they wish. And you could do so without permission, without asking anybody, and likely still compatible with any piece of infrastructure that is built around the foundation, so long as your implementations also implement the functions described in the interface. Obviously, in your creative way, it doesn't have to be in the exact same way that these contracts do so, but they have to be defined in standard form. For instance, pay must have these arguments, and it must return this value here. And that's it. That's how payment terminals are thought about and architected.
Thanks, Jango. I'm wondering, like you've mentioned a few times you've used the word creative a few times. I'm curious to know, like, could you give us an example of if someone was going to write their own terminal, like what kind of things could be done? Like what are some things that could be built? Like could be as wacky or as simple as you like, but I'm just curious if we could have a couple examples of what could be dreamed up in this framework.
Sure. Yeah. So we're just getting done really focusing on the delegate extensions in the JB ecosystem. And those are really powerful because you can add an address into a funding cycle, and that address adheres to pay delegate or redeem delegate or some of these things here. I'm going to remind us where that gets called. So you call it pay. You do a little bit of error handling here, and then you call this internal function pay. So it's like, here's the actual body of the work. Here's just some checking. So I'm going to go down to pay. Here we are. So if delegate allocations.length is not equal 0, so essentially what's happening is the data source is going to, it's going to check with the funding cycle to see if there's a data source attached. If so, it's going to ask the data source, which delegate should I call the did pay hook of? And if there are delegates specified there, it's going to loop and actually call those hooks. So it's going to package up some information, and then eventually it's going to call did pay right here. This is where it hooks into that delegate body of code that we've already seen you can do pretty creative things within. Yeah, the hackathon had some really, really great examples of things you can do here that augment the pay functionality. And you can do anything. But this data that gets passed in here is just some contextual data, like who's paying, how much, who's the beneficiary, yada, yada, yada. But you can be pretty creative here. And without running or rolling out a lot of your own code, since all you have to implement is did pay. But you'll notice did pay is contained in a broader pay function, which is contained in a broader, the top level pay function here that we were at. And so if you really want to get really crazy, instead of just implementing a pay delegate that takes all of the other standard, quote, standard Juicebox stuff and just augment a did pay hook, you could roll out your entire pay function as a different thing, right? So basically, let's take this open-ended idea of projects can bring their own data sources and be like, no, let's take one of these data source implementations and bake it straight into pay. And this is the way it is. This might be practical if maybe you're very sure of that constraint and you want to optimize every other condition out. So you just want to bake in that condition in here. And that way the routine is very gas efficient. It doesn't have to do anything else. It just kind of runs. It doesn't have any flexibility, or it may, it depends on what you write here, but it's very open-ended what you do. So this is kind of one nest of composability outside of the delegates and data sources. The delegates and data sources are your smallest nugget of composability. You can just attach them to funding cycles and they'll just roll on. But if you really want to do something that's one step above, you can do something directly in Pay and take all this information as context and then attach that payment terminal into your project and set it as your primary and start receiving funds there instead. So it's kind of like a superset of everything that delegates and data sources can do.
What would be the advantage to rolling a terminal in this way versus just using a did pay hook? Like basically you would be able to have more control over what would be contained within this. So you'd be able to potentially even like scope it down to make it more gas efficient, or like what would you be gaining by going about the implementation in this way as opposed to just working with the delegates?
That's a good question. Well, I guess we have to be kind of creative about this. I don't have any particular answers in mind apart from it's nice to have the flexibility in case, in our kind of JBDAO internal case as stewards of the protocol is like, if there's something broken, it's nice to create another version that has the same expectation. So everyone who was interacting can still interact the exact same way they did. But there's something in here that's slightly different to fix a certain line of thinking. That's kind of like worst case scenario. I think a lot of what you can do here, you could also do in the data source delegate world. However, if you were doing the data source delegate world, you'd be using the same kind of broader context of what's in the payment terminal that those data source and delegates were being called from. For instance, this broader context here, like it uses a particular IJB projects, it uses a particular directory, particular split store, particular prices store. And so it has these kind of more contextual environment pieces that make the whole JB ecosystem work. But maybe you want to count on a different split store. Maybe you're rolling your own split store and you want the functionality to kind of adhere to that. I guess it's less relevant in Pay there. Or hell, maybe you are receiving a payment and you want to use the split store and just go ahead and split the funds kind of inline in Pay instead of doing so in the distribute payouts of call. You could still do that in the delegates. So it's kind of a tricky question because I think a lot of functionality does overlap, but you just have a broader context to work with. But in so doing, you are likely going to start breaking compatibility with other versions. Data source delegate, everyone can use the same terminal and just roll different data sources and delegates. If you were to implement it at the payment terminal level, everyone could roll their own payment terminals, but then you just have a more of like an organizational difficulty kind of creating like these indexes of where like certain payments should go, especially if you start rolling your own directory and your own projects. But some folks want to have the flexibility to run their own versions of all these contracts and maintain their own front ends that maybe reference kind of their own contracts here and aren't cross-compatible with other clients that are kind of plugged into the Juicebox ecosystem. So there's like, more abstract ways. And I think that's the best answer I have now. I wish I had a really like a creative case that I was very excited about sharing. But I think that we've kind of, all those bits of excitement have also been designed into the data source delegate pattern such that it creates more ease of use so that people don't have to roll their own payment terminals. And they can just lean on the ones that are tried and true and safe. But you can get pretty wild.
Cool. Makes sense. I'm curious about the contract that was written to accept ERC20s instead of ETH, instead of like as a payment to a project. Like I'm wondering how complex was it to write a contract of that nature? Like if I want to write a contract for a project to be able to accept Pepe tokens or what have you, like how complex is that, and what does that look like?
Sure. So we looked briefly earlier at the JB ETH payment terminal 3.1.1, which is the one that we spent most of the time here on JB Payout Redemption Payment Terminal. And it does only a few things, right? First, you have to make it. And by making it, basically, it's like you have to make the superclass, the JB Payout Redemption Payment Terminal. And this contract here has a few expectations. You need to pass in the one token, the decimals, the currency, all this stuff from the single token payment terminal, as well as all this other stuff. And it has to implement these two functions, balance and transfer from, which are requirements that JB Payout Redemption Terminal need to do its stuff. So I'm going to go back. For instance, let's look at pay. So the generic JB Payout Redemption Payment Terminal 3.1, when you pay it, it's going to first check if this current terminal that we're in is one of this product ID. Then it's going to say if the token is not JBTokens.eth, if the token that this contract here is facilitating as a single token payment terminal is not ETH, then what we want to do is kind of go in and do some balance checking. So make sure there's money sent, get a reference of the balance before this operation, transfer from. I'm going to do a find here in this document, transfer from, and then I'm going to write function before it so I can find the implementation. So transfer from here is basically, it's called a virtual function that you can add in abstract classes that basically say, I'm going to roll out a function here, but whoever says that they are a JB Payout Redemption Payment Terminal needs to overwrite this with what they actually mean. So it's just going to say transfer from as like a vanilla version of transfer, and before transfer to as in a vanilla, and then cancel transfer. So a few of these virtual functions, which is what we were using in that pay call. So transfer from the person paying to this contract, the amount. So we want to transfer into this contract. We're assuming that if this is an ERC20, the message sender has already allowed this contract to transfer this amount in. And then we want to just verify that nothing else happened in this transfer from. Since you're rolling your own ERC20, you can manipulate the balances. So we just want to do some sanity checking to make sure that the balance is what we expected it to be. And so really the interesting thing is what happens in transfer from here. If it's an ERC20, it should behave differently than if it's any other token. In this case, we've already kind of taken out the case that it could be ETH, but there's other cases around the contract. Let's find one. In redeemTokensOf, obviously at the end of the redemption function, you want to send the amount that was reclaimed to the redemption beneficiary. So in this case here, all this abstract contract cares about is that at this point in time, I'm going to just transfer from. It's going to call with this address to the beneficiary and the amount reclaimed. And so when thinking about implementing versions of this abstract class here, I'm going to go to the ETH version again, and then we'll hop into the ERC20. All we really want to implement is, all right, how do we do this in the context of just ETH? And how we do this in ETH is it's just an address that you send to, right? So send kind of to in this amount here. You're never sending from anything else except for this contract. So this is all you need to write. But in the ERC20 payment terminal, it's a little different, right? So transfer from is this function where the function of the current token that I'm managing, and I want to do this whole safe transfer operation. And I want to do it differently if the tokens are being sent from the current contract or if it's being sent from some other address. In the context of that pay transaction earlier, I was actually sending from the payer into this contract, given allowance from the payer. So all we really need to do here in the generic ERC20 case is implement these functions, transfer from, and these before and cancel transactions. In the before case, whenever I'm transferring ERC20s to an address, I just need to increase allowance for the address I'm sending to then be able to pull the balance from my account here. And then the only other thing is when you deploy this payment terminal and you construct it, you can specify which ERC20 you're actually talking about here. So for Pepe, for instance, you would send the token here as Pepe, and Currency is relevant if you might have to be dealing with conversions. So trying to figure out how much is Pepe worth compared to 1 ETH right now, or whatever. You need to specify a currency that's compatible with the pricing contract. And then some other information that's just kind of generic to payment terminals that we can go in the weeds for, but they should be pretty self-explanatory. And that's it. So it's just a matter of deploying an ERC20 token with, or an ERC20 payment terminal with that token specified.
So really the heavier lift is more like implementing that in a front end that can account for something other than ETH. Because, I mean, at least from a contract side, this seems relatively straightforward to implement. So I'm just curious because thinking about like Juicebox, we're still only using ETH. So yeah, I was just curious to think about what it would take to accept like USDC or DAI or something like that.
The heavy lifts are definitely designing the abstract class that can handle this arbitrary layer up. All right. So the abstract class never gets implemented, but it's designed such that you should be able to bring that relatable layer, the ETH layer or the ERC20 layer, and it should work the same. So that's the heavy lift. And the other heavy lift is definitely the front end, which has complexities across the stack, right? It has create flow complexities, it has project page complexities, it has settings complexity. So it's definitely like it opens up a whole another set of things that you have to take into consideration when designing anything. That's usually what the bottleneck is. It's like, okay, what's the priority right now? And given that something is a priority, you probably want to reduce complexities in other vectors. So if for instance, if we're dealing with versioning things, like the actual implementation of JB payout redemption payment terminal is going through these .1 progressions, with some frequency, meaning we're finding things to improve, we're finding problems to solve, or very core things to improve. It's better if we haven't already started to make a ton of dependencies on the layer above. It's better that we're not managing .1.1s of like a bunch of ERC20s and a bunch of kind of ETH payment terminals. So it's nice that we have like canonical ETH payment terminals that we can kind of linearly version up. But at a certain point, I think the big unlock will certainly be how do we do these other payment terminals that support other currencies? And I think at that point, what we won't want in making that effort successful is also be dealing with other complexities like versioning or like rewriting certain bits of the project or create flow. That being said, it's very nice from a user experience perspective, if you're designing a user experience, to have in mind the fact that this is very possible and that soon this might be on the table and that soon, in thinking about create flow and project page, this might be a consideration that folks have. So there's like UX complexity there. And then there's like the programmatic complexity, which is an opportunity for bugs to arise that you kind of want to keep scoped. My current thinking is a little bit more oriented towards, instead of like doing a big curtain unveil and now JB supports DAI payment terminals, for instance, across the board, like from the pay side all the way to the project page side. I think it'd be very interesting to have a thesis of a project that needs to be run with a particular token. And then we scope all of the front end interactions, both code and user experience, to that one project page. That way we won't kind of risk people just creating arbitrary projects with that payment terminal and kind of create an open-ended risk in that sense, but rather we can have one project that is running with a particular ERC20 payment terminal, and we can start to kind of inch our way up and scale up into this more full-fledged, fully featured ERC20 multi-token world, which is not something we started with. We're very ETH maxi currently still, and it has afforded us some flexibility in other realms, but there's a ton of opportunity there to make Juicebox compatible with other communities and create treasuries of different token types, et cetera, et cetera. And I'm very excited about it. So in the long arc of what's going on, that's definitely a soon proposition.
Awesome. Thanks, Jango. Electron or Lawrence, do you have any questions or anything that you want to ask Jango? I'm just curious if anyone else has some questions or things that they want to dig into.
Right on, y'all. This was fun. This was like a tongue twister for sure. It's hard to come up. It's hard to name things in general. That's like, that's programming's number one hardest thing. So if you're becoming a programmer, they tell you there's a bunch of semicolons everywhere, but the real difficulty is naming things. And I guess developing a structure that should accommodate open-ended flexibility, but should also be very precise in what it does is also a little bit of a tricky architectural thing. I'm pretty stoked with how it turned out from a architect perspective, but I can definitely empathize with this being a pain in the ass to read and try to reason about when you're trying to be creative with the extensions, with the extensibility of the protocol. So we'll surely revisit this a few more times with some new visuals, new examples, etc. But hopefully this is a good primer of how and why things are organized the way they are. And if you have any questions over time, feel free to reach out. And if you have suggestions, also feel free to reach out or open pull requests or whatever. Thanks, everybody.
Thanks, Jango.